Okay, I began the lecture for Centroid by talking about just 4 or 5 generic types of geometry that we have. Again, the more calculation is gone into like when we use integration to calculate center of gravity, and that's happening in calculus 2. But today we just want to talk about some sort of generic shapes. We have a rectangle. Rectangle has a base and a height. So the area of the rectangle is BH. Very easy, base times height. Not much of thinking about it. Where the centroid of a rectangle is? Anybody knows it? Where the center of this phone is?
Half base, half height.
Yeah, exactly. It's right in the middle, right? Very easy to get it to know. So if the centroid is for this one is right in here. I don't need to do any thinking of it. So it will be half base, half height. Next question would be related to triangle. So triangle, the area of it, we already know it from grade 5, is half of BH, half of base times height. But where the centroid of rectangle is. So again, I always had this fun that I use a piece of paper, and then on a piece of paper I find the centroid for it. So again, you can use the same example to find the centroid of any triangle. So basically, if you look at a triangle like what we have there, you cannot say that the centroid is in the middle, right? Because in the middle, you don't have like the same area or contribution in the middle of each of them. So let me create this triangle. It actually cut it a part of it. This is an example of a triangle, right? So I cannot say that it's in the middle. If I put it in the middle, it will not stop on my hand, right? It will fall off. But the way that works is that if you look into majority of the area is within 1/3. So if this height here is for instance is 1, I can say the centroid is 1/3 from the top, or 1/3 of the height. Again, in this case here would be 1/3 of the height here too. Then if I put my finger here, it will stop on my finger. Again, I can just use a pencil on that location. It would require me to go back into like use a real measure tape. It stopped there momentarily. Look at there. You don't see it, you see it from the height, but that's how it works. It fall off. So 1/3 of the height. That's where the centroid of a triangle is. So 1/3 of the height, meaning that if I know the height here, the centroid on this location will be 1/3 of the height. So in a circle, not much thinking, area of a circle is pi r square. Centroid of the circle is, oh my god, too much thinking, right? Right in the middle, right here. So if I go into a semicircle, the area is easy. It's half of pi r square, will be half of the area. But where is the centroid for this? So from one location, like on the x, in this case, I know it's in the middle here, right? So it's actually half of diameter or just the r. So that's where the location on the x. So will be on the y. Anybody know about that or no? So a semicircle look like this is 4r over 3 pi. Again, you can use integration to get to that location, but this is 4r over 3 pi. A quarter circle, again, is a quarter area, and then the location of it from each side would be 4r over 3 pi. And then in the other side is 4r over, just checking to make sure, put them right, 4r over 3 pi, same thing here. I'm talking about this distance, right? There, and this distance here. Both of them are 4r over 3 pi. So let's talk about composite shape. This is shape that we can consider, but I have areas like this. I want to find the centroid for a composite shape like this. How can I treat this types of problem? The way that works is that if you want to find the centroid of a composite shape, what you do, you break it down to smaller components and then you label them. Like for instance, in this case, I can have 3 shapes. I have a square here 1 by 1. So I'm going to call this one 1. I have a shape here 2 by 3, this rectangle up here. So I'm going to call this one, label this 2, and then label the triangle 3. Already given to me, the x-axis is this way, the y-axis is this way. Now I have 3 shapes. Do I know the center of each of these shapes? Of course I know. But how can I find the centroid of the all area? So I know the center of the first one is right here. Right? I'm going to label it. The center of the second one is right here. The center of the triangle. The triangle, we said that 1/3 of the height from each side. So 1/3 of the 3 from this side will be 1. From the other side is 3, 2. So it will be somewhere here. So if I continue it up, it will be somewhere here. That's the center for 1, center for 2, and center for 3. I already know the center for these 3, but how can I find the center for the combined shape or the composite area? Now, the way that we do it, there is something called weighted average. So the equation for the weighted average, I'll just give you one example. In one semester, you take 3 credits. Your GPA for 3 credit is 4.0. In the next semester, you take 7 credits. And your GPA for 7 credit is 3.0. Can anybody tell me how much your overall GPA is for these 10 credits? Very easy question. All students are working on it every day. So hopefully...
Total credit average divided by the total GPA.
You need to get into an equation, right? So it wouldn't be very simple. So again, remember, total I have 10 credits in 2 semesters. In one semester I have 3 credits, I got 4.0. The next semester I have 7 credits, I got 3.0. Your overall GPA would be 3.5 or no? Or less? It will be lower.
Divided by overall GPA.
Not divided by overall GPA, divided by overall credit. Right? So that will be divided by overall credit. But you came close. So what's happening is that you do 3 times 4, you do 7 times 3, you add these 2, and then you divide it by your total credit, which is 10. In this equation, I have 12 plus 21. So I have 12 plus 21 divided by 10. The answer will be 33 divided by 10. So your GPA is 3.3. Now what I did in this case, I weighted with your credit. Now in this example, we're going to weight them with the area. We know where the area is bigger, the centroid will be closer to that point. So that's why we use the equation for weighted area. So the equation for weighted area, it looks like this. X is equal to, we call it X bar, that's the centroid on the X. We call it Y bar, that's the centroid location on the Y. This will be sum of AX bar for each of them divided by sum of A. We use the same thing for here, sum of A, Y bar divided by sum of A. Again, what I'm writing here is too much work. Why is too much work? Because I need to find X bar for each of them. I need to find the Y bar for each of them. I need to find the area for each of them. I'm going to lose my work. So what will be the solution? The solution is a table. Let's create that table. So I create a table like this. In this table, I call it 1, 2, 3. So this is actually, I have 1, 2, 3. Depending on number of constituents I have. In this case, I have only 3 parts. So for each of them, I'm going to find the x bar for that. I'm going to find the y bar for that. I'm going to find the area for it. Then I'm going to find the a times x. And I'm going to find at the end, if I have a times y bar. In this table, I can add all the areas together. Here I'm going to get sum of a. In this column, I'm going to get sum of a x bar. In this column, I'm going to get sum of a y bar. That's easy. So let's do that. For the first shape, shape 1, where the center of this located. So it's, again, the center of this, this is your origin, by the way. This location is 0, 0. So the location of A, I know from here to here is minus 2.5. So the shape 1, the center for that on the x is minus 2.5. On the y is 0.5. Again, from here to here is 0. The overall height is 1. Half of 1 will be 0.5. So the center here to there is 0.5 on the y. On the x, I need to go all the way back. So the second shape, shape 2, the center is located, the overall height is 3. On the y will be 1.5. So this distance from here to here is 1.5 on the y. On the x is half of 2. So on the x is 1, on the y is 1.5. Going to shape 3. The shape 3, as we discussed, this distance here is 1/3 of 3, right? 1/3 of 3, which will be 1. That side is 1. The other side is also 1. This is 3. This distance here will be 1/3 of 3, which is 1. So I have 1 and 1 for that. So let's move on to the area. The area for the first one is 1 times 1 is 1. Area for the second one is 3 times 2 is 6. Area for the triangle is 3 times 3. So it's half of the base times height. So half of 3 times 3. The answer is 4.5. So it will be a game from here on. Minus 2.5 times a, I want to find a x bar, right? Minus 2.5 times 1 is 2.5 minus. Then 1 times 6 is 6. 1 times 0.45 is 4.5. I go to a times y bar. 1 times half, 0.5. 1.6 times 9 is 9. That's the answer. And then 4.5 times 1 will be 4.5. Let's from now add them together. The sum of A is 1, 6, 4.5 is 11, 10, 11.5, right? So that's the overall area for this shape, 11.5 feet square. A times x bar. The sum of that is 2.5 minus this is 2 will be 8. That's what I got. You can check my answer. If you see something wrong, let me know. And then I have 9 plus 4.5, 13.5. And then plus half there, I'm going to get 14. So I can come to an agreement and then get my answer. So in my answer, I'm going to get x bar is equal to sum of ax. Sum of ax is 8 over sum of a, which is 11.5. And y bar is equal to 14 divided by 11.5. So I'm bringing my calculator in to finalize the answer. 8 divided by 11.5, that's 0.69. And then feet for y bar, 14 divided by 11.5 is 1.2. Kind of makes sense to me, because you see the way that work is it's telling us that our x bar is 0.69. It depending on the area. I have doubt on this. The reason I have doubt on this because I forgot to put the negative here, right? The x location for this triangle was -1. That will make this -6, right? And that will make this a 2. So 8.5 minus 4.5. So So this is becoming 8.5 minus 8.5 will be just minus 4. So this will make the sum of ax minus 4, and that will be minus 4. Minus 4 divided by 11.5. The answer is minus 0.35. Minus 0.3. The more exact is 3.48. This makes sense, right? Because majority of your area is in the negative x. If you look at this, you can see 7 of them is in the negative x, and 4.5 of them is the positive x. So overall, what I would expect is that it has to be on the negative one, and the answer came kind of right in this location. Then for the y, majority of your area is on, again, this is actually is in 1.5, but we have a little area in 0.5 and some area at the height of 1. The overall average will be 1.22. That's how we calculate centroid for a composite shape. I have a couple more examples that I'm going to go skimming through them. So in this example, I have a trapezoid and a circle. The circle is empty. I want to find the centroid for this. When we have empty area, meaning that your area is negative. Such area doesn't exist. So if I keep this in mind, I'm already done. So I'm going to break this one down into constituents. In this case, I'm going to have one constituent like this, one rectangle, one triangle, right? So this will be 1. The second one is the triangle, and the third one down here, that's going to be an empty circle. That will be 3. So my job is to find the center for each of them. The center for 1, the first one, the center for that, this is the x-axis, the y-axis. So the center will be 0.1. So for the shape 1, I can actually draw that table I was talking about. Shape 1, shape 2, shape 3. And then put here x bar, y bar, a. Then ax bar, ay bar. So for shape 1, which is this rectangle, the x is 0.1, the y is 0.3. The area of it is 0.2 times 0.6, which is going to be 0.12. Now for the second shape, shape 2, this side is 0.6. The center is located somewhere here, 1/3 of 0.6. So this distance is 1/3 of 0.6, which is 0.2. Now you have 0.2 plus 0.2. On the x will be 0.4. So is 0.2 here? You remember that we have to go to the origin to calculate the x and y. For the second shape, the height is 0.3 here. So 1/3 of this. So the height here, the height will be 1/3 of 0.6. We are talking about the big triangle, right? Not this one. So this height here is 1/3 of 0.6, which is 0.2. The area for the rectangle is 0.6 times 0.6. If you do that, you're going to get 0.18. And then the third shape, the circle, the center of the circle is located at, if you go from here to here, that's where the center located. So 0.2 this way, and then the other way is 0.3. So 0.2, 0.3. The area of the circle here, the diameter is 0.2. Diameter is 0.2. The radius is 0.1. And the area will be equal to pi 0.1 to the power of 2. The answer is times 0.1 to the power of 2, 0.0. So where the possible mistakes I have done so far is the fact that I am neglecting the area. The area is negative. That's the empty hole. So I have to put the negative here. So the rest of it again is a game, right? So this times this is 0.012, I'm guessing. And then I can continue the same thing. So 0.4 times 18 is 72. So 0.072. And then the last one is 0.2 times 0.0314. This will give me 0.00628. And that's a negative. So I repeat the same thing for the y. And then I'm going to get the top one. I'm going to get 0.0306. 0.2 into 0.18. The answer is 0.06. So moving on to the next one, which is this one. 0.3 times 0.314. Get 0.0942. There's a negative there. So you can add this together, the sum of a, x, and then I'm going to find the sum of ay down here, and I should be good to go. And then from there I can find the centroid of this combined area, and then sum of a from here too. So go back to the equation that x bar, the centroid for the overall area, is equal to sum of a x bar divided by sum of a, and same thing for the y bar for the whole area. So you can continue this experiment. The third question I have, which is very similar to the other two, in this case I have one bar on the top, another bar here, and then a circle at the bottom. So in this case, if you want to calculate the centroid for the composite area, so you could label them, this one 1, this one 2, and this one 3. I'm going to assume, again, they asked me y bar here. What you could do, you could actually assume that your x is, I can start from the top. I don't need to go to the middle of that. I'm going to say this is the x-axis, and the y-axis, I'm going to look at it as going from the middle of this, going down, from the middle of the circle. I could do it like this, right? Again, y could be the other way around too. It doesn't matter how you want to consider it. As long as you are consistent, is all good to go. So shape 1, the center of it will be located at x at 0, right? So shape 1, x bar is at 0, y bar is at 15 divided by 2, which is going to be 7.5. Okay, because I assume the y this way, I don't need to put a negative, right? So the second one for this guy, which is 150, the center is located in the middle, which is going to be 75. From here to here is 75. So 75 plus 15. So shape 2. X bar is still 0. And y bar for that shape is equal to 75 plus 15, which is going to be 90. The very last one, the 3, which is the circle on the circle. The center is here. The radius of the circle is 50. So you are coming 50 down here. So 50, 150, and 15. So it will be 215. 215, and x bar is equal to 0. You don't need to do any calculation on the x bar because we know the centroid will be located because it is symmetric from both sides. No calculation is needed. So I have 1, 2, 3, x bar, y bar, a, sum of ax bar, sum of a, y bar. So you can just repeat the same thing here. Again, I told you x wasn't really needed, x bar wasn't needed either. So I have 7.5, 90, and 215. The area for the top one is 15 times A1 is 5 times 150. A2 is equal to 150 times 15, same bar but cross the other way. And then the area 3 is equal to pi 50 to the power of 2. If I do one of those, I'm going to get 2250. And then the next one is 2250 as well. The third one is pi times 50 to the power of 2 is 7850. So will be simple, right? You just multiply this by that, put it in here. I'm going to just do the first one. 7.5 times 2250, 16875, and then you can continue for the rest of them. So in your y bar will be equal to sum of the area that you got from here. Again, there is no sum in there, right? The sum can come to the bottom. And then you find the sum of a here. So there is no sum here, there is no sum here. Sum will be at the bottom. That's how you can calculate a bar. So I'm done with the first lecture about how to find the centroid of composite shapes.